Hi guys, in today's video we're going to take a look at what are crystals, types of crystals, introduction to dot formulae, determining dot formulae, looking at empirical formulae and experimental results. We'll take a look at some exam style questions and finally a summary.
So the first key point that we have to look at is what is a crystal? Well, we know crystals are shiny and bright. Well, the definition of crystals that we have is a substance whose atoms are regularly ordered in a regular three-dimensional pattern. And we're going to look at two different types of crystals. Those are the hydrated and anhydrous crystals. Hydrated crystals contain water in their structure. We refer to this water as the water of crystallization, whereas anhydrous, as suggested by its name, contain no water in their structure. Now, the colours I've used here to represent my two diagrams of crystals are just for illustrative purposes. It may remind you of copper sulfate, which is a well-known crystal that when hydrated is blue and when anhydrous is white. But by no means is that a hard and fast rule for all crystals. So now I've had a look at different types of crystals, let's have a look at the formulae we use to represent them. The formulae we use to represent our hydrated crystals is called dot formulae. Hydrated crystals, as we've explained, contain water in their structure, that water of crystallization. Now, different crystals contain different amounts of water, and the amount is shown by our dot formula. So here we have the dot formula of that copper sulfate crystal that we talked about, the hydrated form. The empirical formula of our compound is given here. The dot in the middle is followed by the relative number of water molecules in the structure. These are our water of crystallization. So now we know what dot formula is, let's have a look at how we can determine the dot formulae. First method of determining our dot formulae we're going to look at is using the empirical formula. So here we have the empirical formulae of a crystal, Na2CH20O13. Following these steps, we're going to work out the dot formulae from the empirical formula. The first step is to calculate the moles of water using the hydrogen atoms present. Well, we can see that we have 20 hydrogen atoms. We know we're going to want to make H2O. So in each molecule of water, there are 2 hydrogen atoms. So 20 divided by 2 gives us 10, telling us there are going to be 10 hydrogen molecules in our crystal. So as we know, the formula is H2O, there is 1 oxygen. So that means we're going to have 10 oxygens. We have 13 oxygens, so 13 minus 10 is telling us there is 3 oxygens left over.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.